Hello and welcome to the latest VEST webinar series. I'm John Forster, your moderator for today's webinar session, where we will share a manifold design workflow on a web browser. Note that today's webinar will last approximately 30 minutes. You'll be able to submit questions or comments at any time during the webinar session by posting in the questions section located within your webinar control panel. Questions may be answered as they are posted, or we'll try to address them in the last 5 or 10 minutes of the webinar. Note that today's session is being recorded and that the audio is muted for all attendees. And if you do experience any technical issues, please use the chat window to alert our support staff. So now it's my pleasure to introduce our speaker for today's webinar session, Megan O'Neill. Megan works closely with VEST product owners to develop and refine concepts and requirements associated with new desktop and cloud product releases from VEST. So thanks for joining us, Megan. Turn it over to you.
Thank you, John, and I'd like to thank everyone for coming to today's webinar on Manifold Design Workflow on a web browser. So what we will be doing today is working from this drawing. As you can see, it's hand-drawn. Pardon my handwriting. I'm sure we've seen better from some sales engineers and probably a little bit worse as well. So hopefully this is kind of the middle of the road for a very simple circuit. You may notice that I've included component type, model code, manufacturer, not too much information here. And if a sales engineer were to give this drawing to someone to create a manifold block that's ready for manufacture, it would take an experienced CAD MD tools user to create that block. What I'm going to show you today is a tool that sales engineers, applications engineers, I've had some people that are outside of the engineering field use it just to see if they could figure it out, and they figured it out in less than 30 minutes. We're going to show you tools that can enable them to deliver assets to design engineers that will reduce the time it takes to get a quote to a customer, to get a block to a customer, and to accelerate that process and reduce bottlenecks. So yeah, we're hoping to show you these products as a bridge between concepts that are drawn on a napkin or drawn like this pretty rough drawing, and functional design materials that are assets that can be used. So with that, let's get to NetSkeme. So this is our NetSkeme window. And we now have the ability to upload your own custom drawing template. So for me, I just use the NetSkeme logo. I use the VEST logo. I just made it on a metric A3. You can use metric templates, imperial templates, whatever you can create, you can upload into NetSkeme now. I'm going to select this. And while that loads, I'm going to start building this drawing over here. So I'm going to put us in full screen. And personally, I don't really like grid mode, so I'm going to turn the grid off. We have a lot of AutoCAD-like snap settings over in this corner that can be changed. We also have snap to grid. I'm going to turn that off as well. So looking at our drawing over here, we've got this power unit. You guys could watch me make a motor and a coupling set and all of that, or I can show you how to add your own symbols. So I made this in advance, this power unit symbol, and I can easily insert it. It behaves as one symbol. I can use it just as I'd use any other symbol that's already in NetSkeme. So from there, I'm going to start building my manifold. I'm going to start by adding a relief valve, so A04B2, what we get, and that's what we're looking for. Add that here. In my circuit, it needed to be rotated, so rotate that. And add our check valve, RV10A01. It's a high DAC check valve. I'll add that right here. And as I'm adding these symbols with their model codes, I can click on the symbol. I can see its model code, model family, check valve. It description, manufacturer, flow, pressure. If I want more information on it, I can look up its data sheet over here, and we'll get more into that later. So I'm going to keep adding. I'm going to add the directional control valve for WE6J6X. Right, and I want this one. And then I'm going to add 2 pilot operated check valves. CACD. And this one. And I'm just going to do a Control C, Control V. Whoop. Control C, Control V. I've got a copy. I can mirror that copy. And to top this off, I'm going to add a cylinder too. So I could have this whole time been using this tree structure to search if I wasn't certain on what manufacturers, what model codes I wanted to use, and I could be looking them up from there. Now that I've almost got all my components, I got to add another reservoir. So now that I've got all my components, I'm going to draw a manifold envelope. Draw that right there. It's represented by our pink box. All of these components outside the manifold, I don't want them to show up on the parts list, so I'm going to use exclude from parts list so they don't show up in our parts. And now I'm going to add some ports onto the envelope and use some, let's see, O-ring ports. This one, C1. I want my caps lock on. One, I'll add it up here. 2, pressure, and tank. Now all of these are number 6 SIE ports. Let's say I wanted to change one on the fly. I can edit that right here. I can turn this into an 8 or whatever is required. So now I'm going to X out of this and I'm going to start making some connections. So I'm going to connect here, and all of our connection line types are up here. I have auto connect on to make this snapping really easy. And as I go, you can see I have jumpers included. I'm going to clean some of these up a little bit as well. Move this like so, move this down here, pink out, and I'm going to make this connection. All right, I'm going to keep connecting. You can see those green dots appear as I'm making connections that show they're going to the right places. We also have control lines, the dotted lines, and there's some of the jumpers. One got a little funny. There we go. All right, so I can move any of these item IDs as well. I don't like when they are intersecting any of the connection lines. I'm going to reassign item ID. I've got A's and B's for identical components. From here, I'm going to make a parts list. Now, if I wanted, I could export that to Excel, open an Excel, and start using this for quoting purposes. This has all of my components that this circuit has. I'm going to make my ports list. And these default to the top corners of the block. They can be moved around. We can select everything here and move it around. And now I'm going to export to an XML so we can open this in a 3D program. But before I do that, I'm going to delete this connection line just to show you that it will pick up on some errors if it's not ready to be exported. So it has me select the manifold, so I'll select this envelope. Oh, and I have unconnected ports in all of these places with the exclamation points. Like I moved a little fast on these. Yep, I did not connect those right. Fix these connections. And still got some errors. Oh, this hanging connection. All right, there we go. All right, so now as I click on these nets, they are going to highlight so I can see this one. We'll call it 1. This one, I like to click on them twice so I can see the difference. This one we'll call it D2 extended. One will be C1 extended. We'll call this tank. Oh, here's C1. Q, and P. All right, so now we're going to export that XML. We'll save as. Save. And we'll go open it in NetBlock. When we open NetBlock, we get a manifold block that's ready to go. We could start inserting cavities on this block from the library, but the easiest way to do it is to take that XML from NetSkeme that we made earlier. Going to browse, open that. And here you can see we have all of our components and all of our ports. So as we insert our components onto the block, we can see that there's a green check mark next to them that shows they've been inserted. And if anyone's ever used MD tools before, this view cube is pretty common in the 700 series, but moving different cavities to different faces has never been easier. You can rotate the block while you're moving the cavity and drop the cavity where you see fit. Pull this over to another face, show how easy change face is. And I'm going to keep inserting. So one cool thing when I make these sandwich cavities is I can use align cavities to align across the block, which is pretty neat. Insert my footprint on the top face. And I can also go to the nets tab and work from the nets. So if I want to finish the tank net, I can start dragging things over from here. I can see everything in that net. It has been inserted. Everything in, we'll finish the pressure net. And add these on the block. Right, I can use this home button to get back to an ISO view. I can look at my list of cavities and see that I have green check marks next to everything. So everything is inserted onto the block. Now I can start making my connections, which is as easy as just connecting colors. So I can select the cavity I want to connect it. But honestly, sometimes it's not quite that easy and you do have to use construction ports. So for now, I'm going to go to the library. I'm going to get to the SIE plugs and start making some construction connections. We do have a new command coming that automatically determines the diameter of the cavities and the appropriate construction port to use for them. That should be available in our next release. But for now, I can assign a net, stretch the cavity, and make connections that way. I'm going to want this one just a smidge lower. There we go. And I can see that I've completed this tank net. Just use connect cavities for basic ones, like so. And I can keep working with these construction ports. I'll use construction ports to finish off net one as well, the one that's red. So turn this red, that in our cavity properties panel. And I'm just going to click the front face of the block when I just want a front view to stretch these out. Insert a construction port to connect them. And now I can just run a simple net cavity. Boom. All right, so we could continue using the construction ports to finish the yellow net and the green net. But for now, we're going to move on to some other functionalities. So I wanted to say what type of CAD model needs to go on this particular cavity. And say, okay, this is component ID 2. This is our HIDAC component. So I go over here, say, wow, this is component 2. If I edit, look at the data sheet, I'll pick me this tab. You can see a rough outline of what the CAD component is going to look like. It's our check valve ball poppet type. Go to insert CAD model, go to check valve. And this one looks pretty similar. So for now, these are all generic CAD models, just to get an idea of where things are located. For DO3 up here, we don't have nearly as many options. So we'll insert this guy up top. We'll see what is over here, component 4. Go back to NetSkeme. Look at component 4. There we go. And we've got that Parker relief valve data sheet. Oh, this looks like a bit of a longer component in there. So all of these we can see kind of what they're like just by using our mouse to rotate, zoom, all of that. I think this looks a little bit more like what the data sheet showed over here. Again, not perfect because they are generic. For now, I'm going to create a manifold layout drawing for this. So first I'm going to name this block webinar demo drawing number 0920 for today's date, revision 1, aluminum, black oxide, and we'll create our drawing. There's errors in the manifold. If you remember, we didn't finish a couple nets, so let's show those errors. So we have CY1, CY2 extended. And if we run the design check again, I'll pull these up and go over to the model, look at the nets. Say, yep, this green net clearly isn't complete. We've got nothing connecting it. Pink net, or oops, sorry, yellow net, same story there. And we've got a dead area 10 intersects with port 1 of 3A. So let's look at 10. I'm gonna hide the CAD models just so it's a little bit easier for me to see. 10 and 3A. Yep. All right, so yeah, we've got this dead area intersection right here. So to resolve that, we want to move over here, and we can our layout drawing again. And at least we've got rid of that one error. So we can continue with some errors in the block saying we haven't completed this entire block and submit this. This will take a few moments to send us an email with some assets we can share with the design engineers. We can also save this as an MBXML. If anyone is familiar with MD tools, they know that MBXMLs can go back and forth. So we're going to save it again as 0920. Okay, you made one today, I'll replace it. And I'm going to go to SolidWorks, get out of full screen mode. At the SolidWorks, bring that over here. And I'm going to want to import that MBXML. You can see we have those same colorful nets coming in, those same connections that we made in NetBlock are reflected in MD tools. This will also work for 700 series if you're more familiar with Inventor. I'm going to convert this into feature mode so that we can make a drawing out of it. We want a drawing that's ready for manufacturing, ready for assembly. MD Tools is the program to create a block that is fully ready to be manufactured. It has all the precision settings, as well as design engineers are more familiar with it. If, as a salesman, you hand this over to a design engineer, they can see we don't have all the nets connected. They might have additional checks, additional customer requirements they have to handle, but they're going to be very happy that this is already 75% of the way done. Like machining drawing. Great. Oh, I gotta save the part. Save. Save. And now, oh, I'm gonna make a machining ID as well while I'm here, just to make things a little easier. Create the drawing. This will take a moment to load, but from this drawing, you can add notes, you can add machining callouts, you can customize machining charts, as well as customize those machining callouts. And this drawing will be updated as the design engineer makes changes within part mode. Okay, drawing mode does take a moment, especially when we've got a video running. There's our drawing. Now we've got to look at some of the machining charts. It will also configure. All right, there we go. Now we've got a fully functional drawing that we can work with from MD Tools. Was looking at that machining chart, and all of these fields are customizable within your own company. So leaving there, we can check and see what type of email we got from NetBlock. I'll go to my NetBlock drawings folder. Here's the MBXML if we wanted it via the email, or if we lost it, it'll still be in our inbox. Open this zip folder. And within this zip folder, we have some simpler layout drawings. As we can see here, they have representations of the CAD models. They have dimensioned working ports. The construction ports are not going to be dimensioned. They're a very basic layout drawing we can use to start to communicate with customers. Back here, we also have the same thing, but shrink wrapped. So for us, shrink wrapped means we don't show any of those construction ports. So we still show the working ports, we still show the CAD models, but we get to hide some intellectual property from the customer when we're having those communications. We also have a step file that I'm gonna take and put over here. And we can open in SolidWorks or Inventor or any 3D modeling program of your choice. A shrink wrap version of that file is also included. That doesn't include construction ports. And I like to use the section view just to show it has all of that information in the step file. So we've got shrink wrap PDF, DWGs, step files in that email. And with that, and we made it to here, and all in less than 30 minutes, coming from this bit of chicken scratch over here. And with that, I'm running out of time. I will hand it back to John for any questions for me, any questions for Best. Feel free to say so in the questions box.
Hey, Megan, great. Thanks for the, if you could leave your screen up, actually, I was hoping maybe you can go to NetSkeme, the standard web page, and show them where they could sign up for a free trial, if you don't mind. The website. Yeah. Just to give everyone in the group here. So you got the free trial there, and there's also information. So as you click that, just maybe you could show them how they can register. Very simple process. You get a 30-day free trial of NetSkeme. No tough questions asked of you. No credit cards. Nothing. And even put fake names in. If you could show maybe where the price is too, that would be great, just so people can see that. We do get questions every once in a while, hey, how much does it cost? So you scroll down there and there's the pricing. We're also going to be coming out with an enterprise version of NetSkeme within the next month, which will allow anyone who has HydroCAD to expose their custom libraries that are created in HydroCAD to NetSkeme users. So there'll be more information coming out about that. And again, if I could bother you, Megan, you're doing a great job. Thank you for the great demo. If you could show on the NetBlock, similarly, how they can request a free trial. And also, maybe show them the pricing on that. Same process, except here it'll send an email. We are going to be adding a self-registration automatic capability for you to do registering. And then you see the prices is very reasonable for NetBlock. And if any of you have used MD Tools, you can see this is again, doesn't do all the things that MD Tools. This is more for sales and getting quotes, but a great start in being able to get to a manifold design. So let's take a peek if we've gotten any questions. I don't see any questions right now, so why don't I kind of go through a few closing notes. So again, if you do think of any follow-up questions after the webinar, just alert us via an email to support@vestusa.com and just provide the details of your question. So Megan, if I could have you pull up, thank you again. If I could have you pull up the last slide of the PowerPoint and everyone can kind of get an idea of what our upcoming webinars are. And you get to see the lineup, and Megan didn't share her video cam, but her webcam, but there she is. So we'd appreciate it if you could complete a short survey at the conclusion of today's webinar, give us some insight on how you thought about it. Tomorrow, you'll receive an email containing a link to view a replay of today's session, and feel free to share that link with your colleagues. Hey, there's Megan. And links are to the upcoming webinars will be included in that email, as you see on the screen here, but you'll actually have the registration links. And as you can see, we have our next webinar will focus on our latest desktop plugin for SolidWorks, MD Tools 980, which was released earlier this month or late last month, I can't remember. But that introduces a lot of new features like group call out and also some reduced load time. So you could look forward to that later in the month. So again, I want to thank you, Megan, and thanks to all of you for attending today's session. Again, if you do have questions, send those in to vestusa.com. We want to wish you a pleasant and safe day wherever you're at. Thank you very much for joining us today.